One thing I want to point out about the scales in all of the fractals is that they are radial and not diametric scales. So basically, if we have a largest feature of 150, then the actual largest feature that we'll see in the fractal will be around 300, and about twice that. So that's one thing you need to remember when you're defining custom sizes. An easy way to see that is we're going to switch this over to a noise and change it to the math pattern tooth rectangular, which is basically going to give us a circle. The output observer also shows the way this works. If we take a look, or sorry, not the output observer, but the function node preview, taking a look at the lower horizontal measure, it is going up to 10 and then also negative 10. So that equals a total value of 20. So we have 10 meters and we're actually getting 20. So that's kind of a good way to think about it, that you're also going into the negative, because most fractals actually do reverse themselves. So I've got a value of 500 meters, and the preview is showing what it will look like over the course of a kilometer. But keeping in mind that we do have 500 equaling 1 kilometer. So just remember that it is a radial scale and not diametric. The previews do compensate for that, which is nice. Changing the vector to match the actual output will change the preview and also make it so the origin doesn't work correctly. So it's best just to remember that you're working with half, and paying attention to the previews is pretty helpful. So it's really easy to mix different fractals together and get some very interesting outputs. One way to control a fractal with another fractal is to extract the origin, or extract really anything that is made available and connect it to another fractal. For most noises and fractals, you can extract the origin and replace it with a turbulence node, which is over here on the left underneath the constant node. And now we can see that it's distorting the outer edges. I do want to note that a lot of the turbulence nodes can produce inaccurate previews. It's going to depend really on the mapping mode you're using. World Standard seems to work okay, showing a correct preview, but sometimes in parametric, object parametric mode and other modes, it is really kind of difficult to really see what's going on until you populate, because sometimes it'll look way too small or look way too large, and that's just something I've noticed with turbulence nodes. But extracting the origin, and the origin is basically where is this fractal showing up? What is its origin? It's a position. If we remove that and take a look, I can type in a value of 1 for the x, and it's going to shift it over about halfway. You'll also find different origin controls and commands, or at least the sensitivity of them changing between fractals and noises. If we take a look converting this over to a simple fractal wavelength can also modify the position. But once we're working with a fractal, the origin is more based on the actual units, which would be, in this case, a meter. The noise is a 1 was the equivalent of half of the size of the largest feature, or the scale. So if we move this over to a wavelength of 1, you can see it also updated my largest feature size. And now when I work and change the origin, it's going to match the actual scale. Since this is a kilometer, and I've set the origin to 500 on the X, we're seeing it move over to the edge 500 meters. So we could also do negative 500 and shift that around. I am going to switch that back to a noise. And what I want to do is use one of the mixes in a combiner node. So that's located underneath the turbulence. And what we can do is mix this together with other noises or fractals. So let's add in a fractal node. Now it is going to duplicate the last fractal I had selected, which was the converted version. So what we can do is just go to the top and switch the type of fractal and then back to a simple in order to reset everything to default. We can connect the blender now to this other fractal. And I'm just going to adjust my gain so that I'm around between 1 and -1. And there's a couple of different modes. The blend mode is going to go between 0 and 1. And what that does is it picks between in a almost direct transition of basically it works like an opacity, just set normal mode, no blending, where 1 is going to equal input 1, which is the simple fractal in this case. And think of it layered, where input 1 is on top of input 0. So as we adjust the transition, we can slowly see input 0 become clear. So if its ratio is at 0, we're on input 0. These also take negative values. One thing to keep in mind. Now you can connect this blender and its ratio to also other nodes. So let's add in noise node, Perlin noise, value. Set it to ridged. And now if we take a look, what we're going to see is our blend being controlled by this value. And it's only going to use the information between 1 and 0 to give the original output amount. Of course, like I said, it does take negatives and will also go over. So if you're using something like multiply or subtract, it's going to increase that even further. Unless we turn on the clip ratio 0 to 1. Then what it's going to do is automatically cut out everything below 0 and cut out everything above 1. So instead of having to use a map filter, we can automatically just clip everything. Unless you want to keep that other information, then what you can do is use the map filter. And now if you want to see a preview of this while you're editing things, you can go inside down here to the lower left and show an editor. Now it won't remember these settings if you leave the function editor and come back, but while you're working on the function, it is quite useful. Also, if you go up to the upper left and select Show All Previews in Graph, it will always show a preview if it's available. So let's take a look at that population. We are still working with scale. So I think I'm actually going to move that over to the density. and just turn off the scale. Now if we take a look, the output is really high. We're seeing that big circle, and there are a few areas that are subtracted. You have to modify this a bit further. In order to see more of a change. And there we can see that mix. So that's a useful way to mix together pretty much any information. Combiner node is one of the ones that can connect to basically anything. The other link color that I didn't mention is the gray link. If it's gray, it means it'll connect to multiple inputs. It'll take different types of information. So this one accepts a number, color, texture coordinate, vector, and then it says also or vegetation, which is, I believe, something as part of view. So the other inputs are not currently available. That's because the vegetation parameters are not available within Carbon Scatter. So using that, you can also set up some very interesting vector manipulations. And what I'm going to do is take that Blender combiner node. Now it is a combiner node set to Blender. There are different combination modes. You can just set it directly to add, subtract, multiply, or divide. Combiner is the only one that isn't totally universal. The combiner node takes numeric inputs and gives you different controls for mixing. I can show you that really quick. You can connect this to multiple nodes. Every time you add a new node, it will also add a new input, so you can add almost an unlimited number, and then it'll give you a list of the amplitude and offset values. Within that, there's an overall control for all the combinations. So now we can adjust the amplitude, multiplying whichever input we want, and then offset is going to raise or lower the numeric value. Offset is also a very useful filter. So to show you that, I'm going to add a filter node. And filters work with numeric information. Most of the math nodes are typically numeric, but there are also some vector controls. So for the filter, I'm going to select the offset x plus a. And what we can do is raise and lower the number. So typically we were working between 1 and -1, but we could raise it up and work between 0 and 2. Or -1 and work between 0 and -2. We could also raise that to a really high number. There's a lot of different ways to modify the offset. If you right-click and go to Math Node Randomness and select the Scalar seed, what this is an offset for in this case number, and right now it doesn't give us a number, but because it's a seed node, anytime we click on the randomize button, it's going to add or subtract a number from this. So that's just raising and lowering it. It's not going to do anything specific to any specific area, just an overall increase or decrease based on randomness. So you can raise and lower things. That's useful for blenders or just large-scale variations that you do want to add randomness to. Another type of filter you'll find really useful, and I mean, of course, all the filters are really useful in their own way, depending on the circumstances. But more of a visual filter is the actual filter node. This will work with information between 1 and -1. Anything that falls beyond that range really won't be affected. So what we can do is just take a graph, and we can choose to show the grid if we want, and modify the information with this graph. Now it is possible to go out of bounds, and you can see that dip showing because of the way this filter is set up. So if that does happen, it's best just to check the number down at the bottom here. We can see if we set the Y to 1, it is not going to go out of bounds. If you go to the upper left, we can set it up to curves. Now because, and this is another difference between view and carbon scatter, is the filter does not have a clamping mode. The clamping mode is used to delete information or cut out information outside of the range of -1 to 1. This one doesn't have it, so if you are going out of bounds and you do need to clip it, a nice filter for that is the ceiling, which is going to take any number you type in and cut everything out after it. So if I set it to 1, everything above 1 is deleted. Now there's an opposite version of this, which is the floor. So we could set the floor to -1, or we could do 0, and that will cut everything out at those values. I like using the map filter primarily just because it gives you a ceiling and a floor if you decide to cut out or clip values out of range, plus you get to modify the inputs. So sometimes map filter is a little easier for that. But if you only want to control just one or the other, because in this case if I want to leave everything on the floor intact, that way I can clip only the upper value or the lower value. Another useful filter is the opposite filter, which is sort of like an invert. It'll basically invert numeric information. So that is pretty useful. So if you want to actually flip around something you're working on and do the exact opposite, you can just add that opposite filter. Pay attention to the node preview, because sometimes if you use the opposite, just because of the way gamma works, in order to actually get the look you're going for, you would need to also add an offset filter right after it. So offsetting it by -1 or -0.5. That also depends too on the range that you're working with. So if you're working with a fractal that's mostly between 0 and 1, you're not really going to see the correct offset in that case unless you raise it. So opposite and then offset are a good combo in order to properly invert something. There is an invert math node. So if you go to the math node and change it to invert, you can also connect that. But if you take a look, it's a very harsh cutoff. It's a lot different, works a little differently with the numbers. It doesn't exactly invert it in the way you would think of, say, editing an image and inverting it. Okay, so I'm going to go ahead and reset the function. We can turn on the scaling and reset that as well, and that's just going to basically remove everything. I do want to show you a very useful object selection input and functions for that, and that is, or output really, it's the distribution, driving the randomness with a function. Our presence, right now, if we control it, we've got the ability to just really control the ratio number. It's all just kind of random within the internal noise. This doesn't really give you a lot of control of exactly where things are at. Distribution allows you to control it with a function to pick exactly where the objects are showing. So I'm going to add a noise to this and change my preview so that I can see things in the actual scale. And we'll work with a gradient rather than value noise. And switch it over to ridge mode. And actually, I am going to switch back to the value just because the other one wasn't going to a full range of -1 to 1. This one is. So we'll just stick with the value. Now, after connecting the distribution, we take a look. We're going to see our presence has changed. Instead of being controlled by a number, a specific number, what it's doing is it's going to take any numeric information passed through the distribution and control specific ranges for each instance type. So since right now we have 4 instances, equal amounts are divided over the course of 2. So -1 to 1 divided across 4. So that gives us 0.5 for each object. In the presence, we can see -1 to -0.5 is for the cherry tree, the maple, -0.5 to 0, and then 0 to 0.5 for the white birch, and 0.5 to 1 for the large dead tree. So now we can see the presence, after I populate, directly linked to that noise. So that's a pretty cool way to distort just with something simple. We could vary it even more. And because I'm going to keep going back to the distribution through there, that is going to refresh my previews. So let's use the variable density to enter the function just to keep previews correct. So if we take a look back at the distribution, as you can see, it takes a numeric input. And noises and fractals start with the vector information to control and decide exactly where the numeric information is going to fall. Give it a position and a scale. But we can also use some of the direct numeric controls for this as well. Slope, for instance, and we'll connect our distribution to slope, is going to give us a value between -1 and 1, which is going to go between 0 and 180 degrees. The reason that we only see 2 instances showing is because it is giving us a full range of -1 to 1, but the slope in itself, we need to basically only use half that information and compress it. So we could either offset it a bit, or we can use a map filter. If you want, you can change the output range to 0 to 180 instead of -1 to 1. So that can make it a little easier. So then I can set my input to 0 to 180 and set this to -1 to 0, actually. Because it's basically a gradient, we can just set it to 90 to -1 to 1 and just clip the out of range values. And that'll give us all 4 objects. So now as the slope changes, every 22.5 degrees, we see a new instance. Now, if we want to make this a little more variable, since we can't use a wavelength or a turbulence node on this because it's not a vector, and turbulence nodes only affect vectors, as you can see. What we can do is multiply by a noise. So we'll add in a combiner node set to blender. Set it to multiply. Add in a noise node. And this way we can modify the slope. And I'm just going to type 0.5 populate. And it gives us a little more variation. I'm going to go ahead and scale that down a bit. And it looks like we'll multiply it by a little less. So now we've got more variation. We could also just subtract, or we can multiply by a really high amount. But once we fall too far out of range, we're going to lose a lot of our control over the distribution. So what we could also do is connect that to the altitude. If you take a look at the altitude, there are a few options. The parametric mode, if you take a look, is going to give us the -1 to 1 output. Does make it a lot easier to work with. Switching over to standard gives us a unit. And as you can see with the internal unit, it's not quite what we need. Default display unit, basically the same. So that's going to give us a numeric information that's going to be equal to the units on our scene, whether it's meters or centimeters, whatever you're working with. Absolute is basically the same output. And the same kind of setup that we would see. Relative to C is going to be an interesting one if it works, because there is no sea level object in Carbon Scatter. That's basically a view remnant. Unless you're going to be controlling something specifically with an external dependency to control the height or grabbing a position, you really don't need to use this altitude for any other mode other than the parametric, unless you want an absolute calculation. So we could also choose to control the density with, let's say, the slope. And that way we'll see it getting a lot denser along the bottom. Now, like I said, that range for the slope, because we're not really going below 90, and I am going to turn off the 0 to 180, and we should see something that extends the range a little better. Let's go ahead and put that map filter back on. 0, 90, clip out of range values, -1 to 1. So basically, where the slope is the most level, where we have the flattest areas, there's nothing, because it's going to give us that -1 value. If you want, you could set that to, say, -0.5. And then that's going to be about 25% density. So -0.8 can reduce that. So it's getting very steep. If you want to adjust the steepness amount, we can make the upper value 0. So about 50% of the density on steeper slopes. So we can also connect to the orientation same way. If we do the presence based on orientation, we'll see them spread out, showing only at specific angles. That's a very realistic way to control plants, because obviously in the shaded areas, different plants grow than in direct sunlight. So that can be incredibly useful. The time input up at the top works in a sense that it does output the time correctly. Basically, it's in seconds. So every second, it will output or add a number 1. So since we're at frame 0, it's going to show 0. If we went, I am working at 30 frames per second. So at frame 1 or at frame 30, it will output a value of 1. So it does work in the sense that it will control numeric information and outputs based on the time, anything that's animated, but the population itself is not going to change other than just that static population you get at the time you populate. So it's not going to change throughout, say, an animation at all. In that sense, it's not dynamic, and those portions can't be animated. At this point, with Carbon Scatter, it's really useful for controlling, say, loading in an animated sequence, which you can load in a texture map, animation map, and then load in an image sequence by entering in a value directly for time. Technically, what you could do is just add a constant node, a constant number, and set it to the time you would want to reach a sequence number, if that's how you want to control it. But if you want it controlled by the timeline, if something you're working on is a little more variable and you want to kind of adjust the time, you could just make changes to the timeline in Cinema, and then it'll update the animation map, and then you can populate. But at the moment, for Carbon Scatter, since that populations can't be animated in that way, you can animate the instances and set animation modes for native objects, but other than that, the time isn't going to be incredibly useful. There's a lot of stuff brought over from Vue that really doesn't have the kind of use it has within Vue, and a lot of things that are really just are somewhat useless. But so keep in mind some of that stuff is in there. There's obviously a lot I could show with the function editor. Technically, I could probably make a couple 100 hours of training for it. I'm only going to spend so much time just kind of going over things. Mainly just trying to cover some of the most useful things you'll find, and try to clear up any confusion for anyone that's really new to the function editor. There are additional outputs, and I do want to mention this, that you'll find within Fractal nodes, and it is going to show up as a second output, detect rough areas. Connecting to this, you can, when you go to select and connect to the fractal, it gives you two options, the altitude or the rough areas. If we take a look, and now selecting the fractal, we see in the information, and what we're seeing is the altitude information. Once we select the link down to the density, now that we're connected to that second output, there's nothing, and nothing is going to show up for this. It's not going to change. In this case, we have an even distribution of, or even density. So what's really being output is 0, because that second output, even after setting our size, because it will start at 0, it won't change unless we're working with two specific types of fractals, the Grainy Fractal and the terrain, or the I was going to say the terrain fractal, but that is not part of Carbon Scatter, and that's part of Vue. So the Grainy Fractal. That's really going to be the only one you're going to find that this detect rough areas is going to actually produce an output. So we can see the range and the scale of the rough area output, and then the actual output. Keeping in mind too that the rough area output is typically a value between 0 and 1. So you will need to map them to use in specific situations. Also, the Grainy Fractal does take a lot longer to calculate if you're using a whole lot of them. but it's a very complex fractal, the most complex one that you'll find within carbon scatter. It gives the most amount of variation, basically, without having to spend a lot of time mixing things together. I also want to just note really quick that anything you find, pretty much every feature, can be published. And that's, if we take a look at within the fractal, where we would see the extract parameter, to the left of it is the publish parameter. So let's go ahead and publish the largest feature. And it'll say Grainy Fractal, largest feature, so it gives the node and what it's controlling. And then we can also set up group. So we can give this a name, we'll call it Fractal, click OK. OK again, and then when we go to the material editor, we're going to see a new tab called Publish Parameters. And this is going to show and give you access to anything within the function editor directly within this tab. So you can set up specific controls just to make it easier to go between the populate and modifying these settings. It makes it a lot easier. So it's a nice quick access to design certain setups and tools and control things. What you can also do with it, which is kind of cool, is since only the variable density and variable scaling have a function scale, if you want, you can actually add your own function scale to anything, any of these different connections. Although they won't show up within the tab underneath it, they will show up in the publish parameters. So let's say we want to control our direction from surface. We'll extract it. And let's go ahead and add a noise node. And we'll go to math patterns and we'll choose onion. You can see that. I'm going to change to a kilometer preview. Okay, so now if we want to control a function scale specific to this fractal on this channel, now if multiple channels are connected to it, it will affect all of them, but it is kind of cool to be able to just access it directly. What you can do is add in a math node. And now if you click on the link and add a math node and it doesn't add anything, that's because the default math node doesn't work with vectors. So what we can do is either add a math node and change it, or we can right click, go to math node, vector operations, and use the XYZ product. The XYZ product can then be plugged into this, or we can select the link and go to add a math node, which will automatically duplicate the last one selected. This scale is then our direction scale, because it's the direction output, so our direction function scale, basically. So now when we go into our publish parameters, we can modify that scale like we would the other outputs independently. And you can see it modifying the direction, although not a whole lot. You can see the changes. So that's pretty nice to be able to add that. Keeping in mind that it isn't channel dependent, so meaning if we also had the scaling connected to that, modifying that number will also modify what we have connected to our scaling. One thing to keep in mind.